Good day everyone. Hello, my name is Christopher Gabales. My topic for today is all about inventory management, which is under the cost management. So in this chapter, the inventory management, there are methods that we're going to use, which is the economic order quantity or the EOQ and the just in time or JIT and the theory of constraints that later on we're going to discuss and how does it works and how are we going to use it or to apply. So the objective of this study describes the just-in-case inventory management model and the EOQ and discuss the just-in-time, the JIT inventory management, explain the basic concept of constraint optimization, and define the theory of constraint and tell how can it be used to manage inventory. Inventory management helps companies identify which and how much inventory to purchase and in what time. It tracks inventory from purchase to the sales of goods. The practice identifies and responds to trends to ensure there are always enough stock to fulfill customer orders and proper warning of a shortage. It exceeds amount of inventory can prove to be very costly. That we're going to use the EOQ model, the JET, and the theory of constraint, that these three methods offers ways of reducing inventory costs and manage inventory costs, describing how inventory policy can be used to reduce costs and help organizations strengthen their competitive, which is the main purpose of this chapter. Just in case, inventory management is an inventory management method in which you keep a little inventory on hand as possible. That means you don't stockpile products and raw materials just in case you need them. You simplify reorder products to replace those you've already sold. So, a traditional inventory model based on anticipated demand. There are three types of inventory costs can be readily identified with inventory. So these are the cost acquiring inventory, the cost of holding inventory, and the cost of not having inventory on hand when needed. The cost of acquiring inventory, this is the cost of purchased merchandise less discounts that are taken plus any duties and transportation costs paid by the purchaser. Now, inventory holding costs, these are the fees incurred for storing goods or inventory in a warehouse. Stored inventory is a liability that hits profit margins and increases business operating costs. These are examples for rent for space, security, depreciation costs, and insurance are among inventory holding costs. Now, the cost of not having inventory on hand when needed, this means that you run the risk of losing sales during a stock out. On the other hand, having too much can also be costly in many ways. Without an inventory management system, you risk this cost in other areas of inefficiency. There are many consequences to not having effective system in this place. So for example, the lack of inventory balance, which causes the stock shortage and overstocking. Both scenarios can result in lost profits and costs you can be avoided. Next is the time consuming. Are you going to spend valuable time and human capital on tasks you don't need to? For example, manually entering data instead of scanning barcode. With the system, you can put this time into other activities. Decrease warehouse organization. When you lack the fluidity of system, your storage space becomes cluttered and difficult to effectively work within. So ordering costs. These are the expenses incurred to create and process an order to supplier. These costs are included in the determination of the economic order quantity for an inventory items. So the cost of placing, receiving an order, these are the example, which is the clerical costs, documents, and insurance for shipments and unloading. Next is the setup cost. So the cost of preparing equipment and facilities so they can be used to produce a particular product or component. So hence, setup cost is regarded as a batch level cost in activity-based costing. Is considered to be a non-valuable added cost that should be minimized. Example is the setup labor, lost income from the ideal facilities, and the test runs. Next is the stock out cost. The stock out cost of not having sufficient inventory. It is the capital loss from the inventory that has become unavailable for the customer to purchase. When customer cannot buy something because it is not in the stock, the business loses money. Example, the lost sales, cost of expediting, extra setup, transportation, etc., and the cost of interrupted production. Next, the carrying cost, which is the carrying cost inventory. So, it is the amount that business spends on holding inventory over a period of time. It is the cost of owning, storing, and keeping the items in stock. Example, insurance, inventory taxes, obsolescence, opportunity cost of capital tied up in inventory and storage. So these are the traditional reason for carrying inventory. First is the to balance ordering or setup costs and carrying costs. The demand uncertainty, machine failure, defective parts, late delivery of parts, unavailable parts, unreliable production process, to take advantages of discounts, and to hedge against future price increase. Economic order quantity. It is an inventory management technique that helps makes efficient inventory management decisions. It refers to the optimal amount of inventory a company should purchase in order to meet its demand while minimizing its holding and storage stock. So, economic order inventory, find the order quantity that minimize the total cost. So, these are the formula. The total ordering or setup and the carrying cost. So, it is equal the cost placing or receiving order multiplied for the annual demand, divide for the number of units, then add the carrying cost unit, multiplied again the number of units, then divide 2. So we have here an example on how to get the EOQ. Now let's assume that we have placing cost or selling cost is 50 per order and demand is 25 units and the carrying cost is 2 pesos per unit. Now, EOQ is equal to square root 2 multiplied for the demand units and multiplied for the selling cost, then divide the carrying cost is equal to square root of 2 multiplied 25,000 multiplied by 50, then divide 2 pesos is equal to square root of 1 million. And the square root of 1 million is 1,000 units. So that is our EOQ. So this means that this should be the quantity of units that should be ordered in order to reap or to gain the benefits of the ordering cost and the carrying cost. Because when you order these units, you will get the least ordering cost and the carrying cost. Meaning to say, if you order these units, ay makakatipid ka or si entity sa ordering cost and the carrying cost. When to order or produce. So when to order is a production starts only after a customer's order. The customer always has to wait on the completed product. While when to produce is the production starts before a customer orders the item, in the hope that the customers will actually order such an item later on. In this case, the customer ideally does not have to wait for the product. Overall, the customers never want to wait for products. If they have to, they would like to wait as a little possible. However, it is not always possible to produce, make, stock, or to produce. And if it is, it may not be economically sensible. This leads to an often overlooked but important distinction between make to order and make to stock. So here an example. Assume that the average rate of usage is 100 parts per day and assume that the lead time is 4 days. What is the reordered point? So what is the reordered point? It is the order that should be placed when inventory drops. So in other words, it tells you when to place an order so you won't run out of stock. So here is how we going to reorder point, get the reorder point. So reorder point is equal to rate of usage multiplied by the lead time. So 4 times 100 is equal to 400 units. Now, an order should be placed when inventory drops to 400 units. So that is how we're going to order. If the units drops to 400, that is the time that we're going to reorder again. Demand uncertainty and recording. Demand uncertainty refers to the external factors that cause demand to unexpectedly increase or decrease. That also needs a demand and recording on the particular activity. That later on it can be used to determine and help reduce the risk and make the financial decisions that impact profit margins, cash flow, allocation of resources, and opportunities for expansion, inventory accounting, operating costs, staffing, and overall spends. So here are an example on how to determine uncertainty and recording. So there's to avoid running out of parts, the organization often choose to carry safety stock. So what is safety stock? Safety stock is an additional quantity of an item held in the inventory to reduce the risk that the item will be out of stock. It acts as a buffer stock in case sales are greater than the plan and or the supplier is unable to deliver the additional units at the expected time. So here are the example. If the maximum usage of the BCR parts is 120 units per day, the average usage is 100 units per day. And the lead time is 4 days. The safety stock is 80. So we have here the formula how to get the safety stocks. So maximum usage is 120, average usage is 100. We have to deduct the 100, the average usage, to get the difference, which is 120. Now then we're going to multiply the lead time, which is 4. So 20 times 4 is 80. So that is our safety stock. So again, safety stock is the extra inventory carried to serve as insurance against the fluctuations in demand. So we have here the EOQ and the reorder point illustrated. These are the formula, the EOQ and the safety stock and the reorder point, which we did discuss earlier on how to get it. So number 2, JIT inventory management, set up and carrying costs using the JIT approach. So JIT reduces the cost of acquiring inventory to insignificant levels by drastically reducing setup time, meaning the process of reducing the amount of time needed to change over a process from the last part for the previous product to the first good part for the next product, which is very important because it will boost a company capacity, increase manufacturing flexibility, and to help to increase overall output. And another is using the long-term contracts for outside purchases. It is using the long-term contracts for outside purchases. It is an agreement for the sale of property where the buyer will pay to the seller installment payment over an extended time on a regular basis, and by making purchases at price higher or lower than the purchase price, privately or through the other provision at any time and from time to time. Now, carrying costs are reduced to insignificant levels. So the carrying costs are reduced to insignificant levels, meaning to say it is based your stock on your consumer's demand rather than expectation. And improve the layouts of your storeroom and warehouses and consider the negotiation terms in your supplier's agreement. So avoidance of shutdown using the JET approach, total preventive maintenance to reduce machine failures, meaning is a lean manufacturing philosophy that centers on achieving near perfect production, that aims no breakdowns, no small stops or slow running, no defects and no accidents. It emphasizes proactive and preventive maintenance to maximize the lifespan and the productivity of the equipment. Another is the total control to reduce defective parts. So total control is a ranging set of techniques that are employed to maximize errors throughout an organization. By doing so, an organization can greatly improve both its profits and customer satisfaction, which requires the involvement of employees across the organizations who are empowered to make changes. Another is the Kanban system to control production. So what is Kanban system, no? So Kanban system is responsible for ensuring that the necessary products are produced in the necessary quantities at the necessary time. We have here the card system is used to monitor work in process. Withdrawal Kanban, a production Kanban, a vendor Kanban. So we have here the example of the card, withdrawal Kanban, production Kanban, vendor Kanban. So as you can see in the card, we can see the item numbers, item name, box capacity, box type, time to deliver, and name of the supplier. And also the name of receiving company and receiving gate. So this represent how the Kanban or represent the card system of monitoring in process using the Kanban system. Managing discounts and price increases. So we have here the traditional and the JIT. So traditional holding inventories attempts to solve the inventories management dilemma through better forecasting, improvements in the order point and order quantity process, or by adjusting safety stocks levels. However, order quantities, safety stocks, and lead time represents only a minority of the sources of inventory problems. And another is the JET, which negotiate long-term contracts, which we discussed earlier in the video. And another is the vendors. So in vendors, we are carefully selection. We have to consider more than the price and close to production facility, establish more extensive suppliers involvement. So next we have JET limitations. Patience is implementation is needed. Time is required. JET may cause lost sales and stress workers, and production may be interrupted due to an absence of inventory. Number 3, basic concepts of constraint optimization. Every firm faces limited resources and limited demands for each product. Meaning to say, it is the scarcity, which in economics, it refers to when the demands for a resource is greater than the supply of that resource. As resources are limited, the scarcity results in consumers having to make the decisions on how best to allocate resources in order to satisfy all basic needs and as many wants as possible. So these are the example, the external constraint and the internal constraints. So the external constraint example is the market demands. So in internal constraint example is the machine or the level time availability. So the constraint optimization is choosing the optimal mix given the constraint faced by the firm. So it is one of the fundamental tools in economic and in real life. Consumers maximize their utility subject to many constraints, and one significant constraint is their budget constraints. That even Bill Gates cannot consume everything in the world and everything he wants. And as also can Mark Zuckerberg buy everything. Similarly, while maximizing profit or minimizing costs, the procedure faced several economic constraints in real life. For example, the resource constraints, production constraints, and etc. So, linear program, a method that searches among the possible solutions. Unit, the optimal solution is identified. So basically, it is a mathematical modeling technique in which a linear function is maximized or minimized when subjected to various constraints. This technique has been useful for guiding quantitative decisions in business planning, in industrial engineering, and to a lesser extent, in the social and physical science. So these are the examples. So the two productions, so X and Y, provide contribution margins of 300 and 600 respectively. So the objective is to maximize total contribution margin. So this is the objective function. So Z is equal to 300X plus 600Y. So here is the constraint data max company. So as you can see here in the data, there are resource name, resource available. So this is the part X resource, usage per minute, part Y, resource usage per minute. So in resource name, there is grinding, drilling, polishing, market demand for part X, and market demand for part Y. So the grinding, there is 80 grinding hours, and then the drilling is 120 drilling hours, and 90 labor hours, 60 units for market demand for part X, and then 100 units for market demand part Y. And the part Y usage per unit is, for grinding is 1 hour, while part Y resource is 1 hour, so they're the same. And then the drilling 1 hour for part X, and for part Y is 3 hours. While in polishing in part X, there is 2 hours, and for part Y is 1 hour. So in the market demand for usage per unit is 1 hour, while the part Y usage per unit for market demand, there's none unit, so 0 units siya. And then the market demand part Y is, in part X, usage per unit is 0, while the part Y resource units is 1 hour. So here is the linear programming. So as you can see here, the X plus Y is less than or not equal to 80. That, as you can see in the constrained data, the part X is 1 hour and part Y is also 1 hour. And next is the X plus 3Y is less than or equal to 120. As you can see here in the constrained data again, part X is 1 hour and part Y is 3 hours. And all of that shows here that 2C plus Y is less than or equal to 90. So the part X here is 2 hours and 1 hour for letter Y. And it shows here all of their representing numbers. So here now it is the graphical solution, that as you can see here, the X plus Y is equal to not equal to 90. It starts with the D represent Y, goes up to 90, no? As you can see here in the graphical solution. And now the X plus 3Y less than 200, it starts here letter X, down goes through 120, 40 going to 120. While the X is less than 60, it shows here from down going up. Next is the Y is less than 200, as you can see here naman, represent here. Now Y is not less than 100. While as you can see here, the D and the A starts with 0 to 40. And while the X here is from A to B, representing their value. The C, the B, and the letter A and D corresponds with their current value numbers. So as you can see here in the table, where it represents their profit value. So as you can see, letter B, so the X here is 0 and letter Y is 40. The profit is 24,000. And the letter C is, the X is value is 30 and the Y is 30. So the profit is 27,000. While the letter D, the X value is 45 while the letter Y is 0. So the profit is 13,500. So basically, as you can see, the letter C is the optimal solution here. It is the very effective and it is the most profitable. So number 4, the theory of constraint, the measures of system performance. So there are things that we're going to measure, which is the throughout, inventory, operating expense, which throughout is the rate at which an organization generates money through sales. And the inventory is the money that organization spends in their turning materials into through output. while the operating expense is the money that organization spends in turning inventories into throughout. So here is the formula. Throughout is equal to sales revenue minus the unit level variable expenses divided by the time. Is the 5-step method for improving performance. So first is the identify an organization's constraints, exploit the binding constraints, subordinates everything else to the decisions made in step 2. Now next is the elevate organization's binding constraints, and then repeat the process as a new constraint emerge to limit outputs. So that's all for now. Thank you so much for listening. I'm Christopher Gabales once again.